Robert Boyle was an Anglo-Irish natural philosopher, chemist, physicist, alchemist, and inventor who lived from 1627 to 1691. He is widely considered the first modern chemist and one of the founders of modern chemistry. Boyle was also a key figure in shaping the modern experimental scientific method. He is most famous for Boyle's law, which explains how the pressure and volume of a gas are inversely related when temperature remains constant in a closed system. His book, The Skeptical Chemist, is regarded as a foundational work in the history of chemistry. Boyle was also a devout Anglican and wrote several theological works, combining his faith with his scientific curiosity. Robert Boyle was born at Lismore Castle in County Waterford, Ireland. He was the 7th son and 14th child of Richard Boyle, the 1st Earl of Cork, and Catherine Fenton. His father, known as the Great Earl of Cork, had come to Ireland from England in 1588, where he quickly gained power and wealth through land and political influence. By the time Robert was born, his father had become one of the richest and most powerful men in Ireland. His mother, Catherine, was the daughter of Sir Geoffrey Fenton, a former Secretary of State for Ireland, and Alice Weston. As a child, Boyle was raised by a nurse, as was common for noble families at the time. He received private lessons in Latin, Greek, and French, which laid the foundation for his education. After his mother's death, Boyle and his brother Francis were sent to Eton College in England when he was 8 years old. Their father's friend, Sir Henry Wotton, served as the head of the school. During his years at Eton, Boyle and his brothers also received extra tutoring from Robert Carew, who tried to teach them Irish, though Boyle preferred studying French and Latin instead. After spending a few years at Eton, Boyle traveled to continental Europe with a French tutor. They visited several countries, including Italy, and in 1641 they stayed in Florence during the winter. While there, Boyle studied the ideas of the famous astronomer Galileo Galilei, who was in his final years. This experience deeply influenced Boyle's interest in science and observation, shaping his approach to research for the rest of his life. Robert Boyle returned to England in 1644 after several years of travel in Europe, eager to begin his scientific work. His father had died the previous year, leaving him the manor of Stalbridge in Dorset and large estates in Ireland. Boyle lived at Stalbridge House from 1644 to 1652, where he built a laboratory and carried out many experiments. During this period, he became part of a group of thinkers known as the Invisible College, who met regularly in London and Oxford to discuss science and the new philosophy. These gatherings later evolved into the Royal Society. Boyle made several trips to his estates in Ireland and eventually moved there in 1652, but he became frustrated because he lacked the tools and equipment needed for his research. He once described Ireland as a place where chemistry was misunderstood and scientific instruments were impossible to find. In 1654, Boyle moved to Oxford to continue his work more effectively. He lived in a building on High Street, near where the Shelley Memorial stands today, and worked closely with Robert Hooke, who helped him build and improve scientific instruments. Inspired by the invention of a vacuum pump by Otto von Guericke, Boyle and Hooke created their own version called the pneumatical engine in 1659. Using this device, Boyle studied the properties of air and discovered that the volume of a gas decreases as pressure increases as long as temperature remains constant. This became known as Boyle's law. Although others like Henry Power and Edme Mariotte also explored similar ideas, Boyle's careful experiments and clear descriptions made him most closely associated with the discovery. In 1663, the Invisible College became the Royal Society of London for Improving Natural Knowledge, officially established by King Charles II. Boyle was one of its founding members and was later offered the position of president in 1680, though he declined because of his personal religious principles. Boyle also had a remarkable imagination. He made a list of possible inventions that included ideas such as flying machines, perpetual light, new medicines, and ships that could sail in any direction or never sink. Many of these predictions would become realities in later centuries. In 1668, Boyle left Oxford and moved to London, living with his sister Catherine Jones, Lady Ranelagh, in Pall Mall. They shared a deep intellectual partnership, working together on scientific ideas, exchanging notes, and editing each other's writings. Catherine hosted gatherings for scholars and thinkers, and Boyle continued to experiment in her home laboratory. Her influence on his work was significant, though later historians often overlooked her contributions. As Boyle grew older, his health began to fail. By 1669, he started to withdraw from public life and limited visitors to just a few days each week. He continued to work quietly on his experiments and writings, preparing what he called a hermetic legacy for future scientists. In 1691, after the death of his sister, his own health worsened, and he died on December 31st of that year. He was buried in St. Martin-in-the-Fields Church in London. In his will, Boyle established the Boyle Lectures, a series of talks intended to defend Christianity through reason and science. Boyle's scientific legacy was immense. He followed the experimental method promoted by Francis Bacon, believing that scientific ideas should be tested through observation rather than accepted on theory alone. He avoided speculation and wrote that he preferred to test ideas through experiments rather than rely on guesswork. For Boyle, knowledge itself was a worthy goal, though he also valued practical uses of science. One of his greatest achievements was improving the design of the vacuum pump with Robert Hooke. Their new version allowed for experiments with air pressure, sound, and combustion. Boyle described these experiments in his book New Experiments Physico-Mechanical, Touching the Spring of the Air and Its Effects, 1660, which became one of the most important scientific works of the century. Boyle was also deeply interested in chemistry and alchemy. Although he still believed in the possibility of transforming metals, he helped move chemistry away from alchemy and toward modern scientific practice. His most famous book, The Skeptical Chymist, 1661, rejected the old belief that all matter was made from just salt, sulfur, and mercury, arguing instead that substances were composed of elements and compounds that could be analyzed through experimentation. He introduced the idea of analyzing materials by breaking them down into their basic components and distinguished between mixtures and true chemical compounds. Boyle also studied combustion, respiration, and the behavior of gases, and he even conducted experiments in physiology, though his sensitivity prevented him from performing dissections himself. Around 1670, he produced what is now known as hydrogen gas, calling it factitious air, meaning an artificial form of air. Boyle believed that heat was caused by the motion of tiny, invisible particles within matter, an idea shared by scientists like Galileo and Hooke. Beyond chemistry, his work contributed to the study of sound, water pressure, color, crystals, electricity, and the expansion of freezing water. Through his careful experiments and insistence on evidence, Robert Boyle helped shape the foundations of modern physics and chemistry, earning a place as one of the most influential scientists in history. Alongside his work in philosophy and science, Robert Boyle dedicated much of his time to theology. He focused on the practical aspects of religion, rather than on controversial debates. After King Charles II returned to the throne in 1660, Boyle was warmly welcomed at court and was even offered the position of provost at Eton College in 1665. However, he declined because accepting it required becoming a clergyman. He believed that his writings about religion would have greater influence if they came from a lay person rather than a paid church minister. Boyle often connected his scientific studies with his faith, believing that nature offered clear evidence of God's design. In his book, Disquisition, about the final causes of natural things, 1688, he criticized philosophers like René Descartes, who claimed that studying nature could not reveal divine purpose. Boyle argued the opposite, that the order and design seen in nature proved God's direct involvement in the world. In another work, Some Physico-Theological Considerations about the Possibility of the Resurrection, 1675, he used ideas from chemistry to explain how the resurrection of the body could be physically possible. Throughout his career, Boyle aimed to show that science and Christianity could support one another rather than conflict. As a director of the East India Company, Boyle used his wealth to promote Christianity in Asia. He donated generously to missionary organizations and funded Bible translations into different languages. He believed that everyone should be able to read the Bible in their native language. During his lifetime, Irish-language Bibles were rare, so between 1680 and 1685, Boyle personally financed the printing of the Old and New Testaments in Irish. This decision set him apart from most of the English Protestant elite in Ireland, who opposed the use of the Irish language in worship and education. Boyle also explored questions about human origins and race. He believed that all humans came from a single pair, Adam and Eve, and that physical differences among people were caused by natural variation rather than separate creation. Based on stories of families giving birth to albino children, he suggested that Adam and Eve were likely white, but that other skin colors could arise through inherited differences. He also linked his studies of color and light to these ideas, suggesting that complexion might result from natural impressions in the body. Boyle's belief that all humans shared a common ancestry was unusual for his time. Some scientists found his theories strange or even amusing, but they represented an early attempt to explain human diversity through observation rather than prejudice. In his will, Boyle left money to fund public lectures defending the Christian faith. These talks, known as the Boyle Lectures, were meant to argue against atheism, deism, paganism, Judaism, and Islam, but they were not to involve disputes among Christians. Through these lectures, Boyle hoped to ensure that his commitment to both science and faith would continue to influence future generations.